Hi everyone, and welcome back to my Meeple series. Today I'm going to be working on giving the meeples some sensing and obstacle detection and avoidance. Once again, if you're curious about what packages or IDE or version of Python I'm using, links will be in the description. Alrighty, we're going to start with the project that I had from last part. And we're just going to edit the vector so that we're using the direction and magnitude like an actual mathematical vector. I'm just going to change our variables in the vector to the direction and magnitude. Just remind myself that these are in degrees and update it in the meeple. I'm just going to pick a random angle between 0 and 360, so a 360 circle around the meeple, and I'm going to pick a random magnitude between 5 and 20. This is how fast it moves in that direction. Then I'm going to write a function that calculates the new position given the current position. I'm going to start by just defining my x and y that I'm going to return later to the initial position, and I'm using that cool Python unpacking. I'm also going to use the Python NumPy library. This is going to give me a bunch of new math functions. For example, cosine, which is what I'm going to need to use to get the new x position. Then I'm going to multiply that by the magnitude because the cosine gives me basically a ratio of how much of the magnitude should be in the x direction, and I'm doing the same thing with the sine function to get the amount of magnitude in the y direction. And I'm just going to return that x and y. Now that we have that new function, we'll update the update function to calculate the new position of the meeple based on its vector. And we'll just set the initial position to its current position. And I'm also getting rid of the random direction change. And looks like they're still moving around. Looks good. Next, I'm going to go on to a bit of a tangent and add some keyboard commands. This is just a really quick thing that I'm doing where if I hit the spacebar, it will pause the simulation and unpause it depending on the current state. I'm also going to add a escape key command to close the simulation. This is mostly to see if I can, and also to help a little bit for recording the simulation. So let's see if that works. First off, it didn't crash, and pause, and go. Looks good. And let's go back to the actual simulation. So I'm going to set up a background so that I can redraw that with whatever is on it without having to know exactly what was supposed to be on there. This will also make it easier for the meeple to detect the pixels because it will just have to look at the pixels on the background instead of the pixels on the game board as a whole. I'm setting it up very similarly to the game board where I have an image and a drawer, and I'm just going to draw a rectangle around the edge so that this will be the border so that the meeple, instead of going through the border and appearing on the other side, will actually try to avoid it. I'm also adding a getPixel function so I don't have to go another layer deep to get the value of the pixel. Now I'm going to set up a sensor class. This will basically tell the meeple how far it can look, both away from it in a radius and the range of the sensor area. So it's basically a pie shape. And I'm just setting this up like our classes before. And I'm going to give the meeple one of these. And I'm just going to put it in with our other initial values right under the vector. And I'm just going to give it 30 degrees and a radius of the size of the meeple times 2. And let's also add a arc so that we can actually see where the sensor is. And this is pretty easy using Pill. I basically just give it a box to go around, just like how I drew the rectangle. And that's just going to be very similar to the rectangle, except I'm using the sensor radius. And then I'm also going to give it a starting angle. And this will be the direction that the meeple is facing, plus half of the sensor's angle range. And I'll do the same for the other side, I'll just subtract it. And let's see. Okay, it's not going in the right direction. Let me just try flipping those numbers. And it's still not going in the right direction. How about, nope. How about, no, still not right. Let's try something drastic. I'm just going to set it to the direction -1, just to see if I can somehow get it to point in the right direction, like something was wrong with my math or something like that. Let's try. That's a lot of circles. Let's try something else. Let's try flipping those and see what happens. So we'll run it, and there's tiny little dots. Still not in the right direction though. Trial and error revealed that I was not converting the direction into radians, which is actually what the numpy cosine and sines take in. So let's see if that will fix anything. There we go, now it's pointing in the right direction. Woo! We did it! Okay, let's try removing those other meeples so that it's easier to debug what issues might come about when we're actually doing the obstacles. Now, I'm going to just change these to ellipses because I like circles. There's a circle, still working great, awesome. Now let's go ahead and take out the respawn on the other side and add a sense function, and we're going to write the sense function. This will basically check every pixel within the sensor range from the beginning radius of 1 pixel onward. And we're also going to check every angle in that pie. And we're just going to do from the sensor angle range divided by 2, just like we did for the arc. I'm just going to rename that to angle because I know it's the sensor's angle range. And we're going to go to the other side of the pie. And just to make this a little bit less cumbersome, I'm just going to move all of these range calculations into the sensor itself because it already has access to most of that information. And this will return a range that we can loop through using a for-in loop. Now that we have that in the function, we can go ahead and just call it in the for-in loop. So that will get every angle inside that range. And we're going to try to get the pixel color for the specific point that we're grabbing. So we're going to grab the parent's background, the game board's background. I'm also going to write a quick little function here to grab the XY position at that point in the arc using the angle and the radius and the center location. The equation I'm using is the same equation that I used to calculate the new position of the vector. I'm just not parsing out the center first. I'm just adding it directly into the equation so I can return everything on one line. Now that we have that going, we can go back to our function and grab the pixel at that edge of the arc using the angle, the radius, and the current position of the meeple. Now I'm going to check if the point color is black. If it is, I'm going to do a turn. I want to make sure that the maximum I turn is 180 degrees, which is just straight backwards. So I'm going to take the ratio of the radius plus 1 and the sensor's total radius and multiply that by 180. So the closer it is to the wall, the farther it turns, and 180. This will make sure that it doesn't go over 180 because I am actually adding 1, so the ratio could be something like 110%. I'm going to pick a random number between the minimum turn and 180. And I'm just going to fix the image issue here because I'm passing in the self. And let's see. And nope. Okay. So I actually had the radius a bit strange, so let's try that again. And it crashed, I think. There we go. Okay, let's try fudging around with the loops a little bit. Let's just try printing out some stuff. I'm going to try printing the point color at the current position and see what that gets us. So lots of white color, that makes sense. Let's see it. It's going, it's going, it's going, and crash. Okay, after lots of trial and error again, I ended up with this code. Now let's see if this one works. And it's going, and it bounces off. Woo! We did it, people! Look at it going. Bounce and bounce and bounce. So let's look at this again and see if we can do anything else. I did notice that occasionally it would crash because it would try to measure a pixel that was outside of the image. So I'm just going to do a try catch there. If it can't find that pixel, it just assumes that is black. I'm also going to make it so that it can't leave the boundary of the image. So if it reaches the edge and it would move into that position, it just doesn't. And after that, let's see what we got. Okay, I also added some more boundaries. So look at it bouncing around on these little circles that I added to the background. Well, that will be all for this episode of the Meeple series. I hope you all enjoyed, and if you did, please like and comment. And if you really liked it, go ahead and subscribe. Thank you all, and I hope you have a safe and happy evening.